Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review the log laws. So these are the 4 laws you need to know. So the first one says if you add logs of the same base, you keep the same base and you multiply together these two arguments. So if you have something like log a to the x plus log a to the 2x, to simplify that, to combine it as one log, you simply keep the same base and you multiply the two arguments x times 2x and I get 2x squared, easy as. So the second log law says when you are subtracting logs of the same base, you can just divide these two numbers here. So log x of 72 minus log x of 8, you simply keep the same base and you divide 72 by 8 here. You get 9, we're done, we've combined it to one log. So the third index law says if you have a second power here, a to the power of b to the power of c, you can simply move this number to the front. So if I have something like log a of 1 over 36, note that 36 is 6 to the power of minus 2. So now I have this second power up here, I just move it to the front. So that will just become minus 2 log base a of 6. Now the fourth one is called the change of base formula. It's where you have a log here and you want to change the base. So I've changed the base from A to C. So it's always this number on top and the original base on the bottom. So that can help us simplify something like this. The change of base formula tells us that that will be log. This number on the bottom will be the base. So that's 243 and the number on top will go here. So log 243 of 729, you can actually just put that on your calculator and you end up getting 6 over 5. All right, let's turn our attention to a more complex simplification of logs. So we're going to simplify this. I'm going to write this as a single logarithm, log base something of something. So because I have log base 2 here, I want to write 2 as log base 2 of something. So which number should I actually put here? Well, I want this to equal 2. So the definition of log is this number to this power equals that. So the number that goes here is 2 to the power of 2, which is 4. So I'm going to rewrite this expression as log 2 of 4 minus log 2 of 3. Now I'm going to do the reverse of the third log law on the previous slide. If I have something out the front, I can write it up here as a power. So this last one, I'm going to write log 2 of 36 to the power of half. So if I combine these two logs using the subtraction rule, I keep the same base and I divide 4 by 3. Now notice that 36 to the power of a half is simply 6. So I can write it like this. So now I'm adding together two logs of the same base. So I simply keep the same base and I multiply these two together. So 4 over 3 times 6 is 8. I get log 2 of 8. Now log 2 of 8, you can put in your calculator if you don't know, it's going to be 3 because 2 to the power of 3 gives 8. So there we're done. We wrote it as a single logarithm and then we're able to evaluate it. All right, let's now look at another problem involving the log laws. So we've got log a7 equals m, log a of 11 equals n. We need to write this in terms of m or n. So that means I've got to write this equal to like something times m plus something times n. So what I really need to be able to do is write this in terms of powers of 7 and 11, because they were the numbers I was given. Now notice that 49 is 7 squared, and 1331, you probably don't know off the top of your head it's 11 cubed, but what you should be doing is saying, okay, well, because I've got 11 here, I need to try and write this as a combination of powers of 11 and or 7. So you could put in your calculator log 11 of 1331 and it would tell you it's 11 to the power of 3 that equals 1331. So I can rewrite this logarithm as log a of 7 squared divided by 11 cubed. Now the log laws on the first slide tell us that we can write this as the difference of two logs of the same base. So we're sort of doing the opposite, going the opposite way of the way I wrote the second log law. So when you have this divided by this, you just put what's on top first and you're subtracting log of what's on the bottom. Now, the third log law tells us if we have a second number up here, we can move it to the front. So I can rewrite this as 2 log a of 7. I can rewrite this as 3 log a of 11. And that makes it nice and easy because we were told at the very start of the question, that is m, that is n, so it's simply 2m minus 3n, and we're done. All right, let's now look at some logarithmic equations. So log laws can help solve logarithmic equations. This is a logarithmic equation because it has an equal sign, so we're solving it, and it has logs in it. So the reason that log laws come in handy is we've got 2 different logs here. We can combine them into a single log. So the rule for adding logs, I'll keep the same base, and then I'll multiply together these 2 exponents, x and x plus 4. All right, so how do I get rid of the log? Well, the definition of a log is this number to this power equals that. So I have x outside of x plus 4 equals 2 to the power of 4, which is 16. So expanding the brackets, this ends up being a quadratic. So we need to make one side equal to 0. You always do that for quadratics. So I subtracted 16, brought it over here, because whether you want to factorize or use the quadratic formula, you must have one side equal to 0. So here is the quadratic formula. If you've forgotten it, you can use that for quadratics as long as one side equals 0. So using the quadratic formula, we have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So of course that equals minus 4 plus or minus the square root of 80 over 2. So note that there are 2 solutions here. We have negative 4 plus root 80 over 2, and we have negative 4 minus root 80 over 2. Now, one of these solutions works and one doesn't. See, when you have a log, positive base like that, this number has to be positive. Reason is you can't raise 2 to any power and get an answer of 0 or negative. So the only possible solution here is negative 4 plus root 80 over 2. We can't have negative 4 minus root 80 over 2 because that is negative and x cannot be negative. So that's our final answer exactly. You can simplify it if you want because negative 4 divided by 2 is negative 2. Root 80 is the same as 4 root 5. So dividing by 2, you get 2 root 5. So that is the final answer exactly. Let's look at one more logarithmic equation. So this is another logarithmic equation because it has the logs here. It has an equal sign, so we're solving for x. We're stating what x equals. So we can use log laws to help us simplify this. The log law says if you have logs of the same base and you're taking their difference, you keep the same base. And we're just going to divide the x plus 4 by the x minus 5. Okay, so once again, I want to get rid of the log at this stage. Definition of log says this number to this power equals that. So we have x plus 4 over x minus 5. Now 4 to the power of a half, square root of 4 equals 2. So to solve this equation, I'm going to times each side by x minus 5. So I get x plus 4. I have to times the 2 by the x. I have to times the 2 by the negative 5. So we simply subtract x from both sides, add 10 to both sides, we get x equals 10. Now double check, can that work in here and here? Well, yes, we can, because 10 plus 4 is positive, and yes, 10 minus 5 is positive, so it works. 10 is our solution, and we're done. Alright, thank you so much for tuning into this video. Best of luck studying, but you'll ace it. You're a star. This has been the luckiest maths teacher in the world. Have a great day.